Hi, my name is Adam Griffin. I will be demonstrating 3 different experiments. Observe, turn on this scope, then the frequency generator, then the high frequency power amplifier. At this point, you see a lamp glowing and the receiver. Observe the LED is now brilliant and changing as I vary the tuning frequency. Further, watch as I move this lamp from the transmitter to the receiver along this wire where it's still glowing. Notice as this is brought into another room, the lamp is still glowing. Substituting this field strength meter here at the receiver, is headed towards 1700 volts per meter at the receiver and beeping a warning tone. Let's look at some of the other prototype parts made so far. See here are 25 millimeter to 500 millimeter diameter excitation coils. How are these made? Let's take a look at the software. First, you can see this design software used to make miniature conductor features that define excitation coil and corresponding spiral coil geometries. Hence performance in creating longitudinal waves. As you can see, the hardware is programmable. The IDE is shown here while programming a test device, and you can see a frequency is generated during this programming check. Next, I would like to demonstrate a fully populated and programmed PCBA or printed circuit board assembly. This platform is referred to as a starter kit. Watch what happens when I press the reset button on this transmitter. You can see here on the display that the transmitter is talking to the computer, telling it what it has done and what it has learned. When the transmitter actually is programmed to do is change frequency applied to the excitation coil 32 times, and each time sniff and report the maximum power it feels was delivered to the receiver. What we just saw is the transmitter's automated power readings. 25 seconds to run through its tests and selecting a frequency based on that learning. Over here at the receiver, the voltage across this 1000 ohm resistor corresponds to 1 milliamp according to the measurement you see here. Remember that this receiver has no onboard power supply. All of its energy is coming from that transmitter. Watch here how I can type a command telling the transmitter to change its frequency. See how the receiver changes its power in response to my typing a command over here at the transmitter? Start again. Let me manually type. It's at step 31. I'm going to change it back to step 28. Observe the phase relationship of the input current from the one wire by adding this Pearson probe reading on channel 2. The Pearson probe is reading the one wire current. Channel 1 is measuring the voltage squared divided by 1000 ohms, or about 700 microwatts. Thank you.